The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you very much, Anna. A very good day to everyone, and thank you so much for joining this session. Welcome to the AI for Good tinyML Challenge webinar session. My name is Thomas Pascal from the ITU, International Telecommunications Union. Today, I'm very excited to host another webinar titled tinyML Smart Weather Station Challenge 2024, The Next Generation Returns. This webinar will introduce the Next Generation tinyML Smart Weather Station 2024 competition. And this competition is aimed at inspiring and promoting the development of innovative, energy-efficient, and cost-effective smart weather stations, and of course, using tinyML technology. The participants for our challenge this year are invited to design, build, and deploy weather stations that can accurately measure and report in real-time environmental data, especially rain and wind. But of course, you can also include other aspects such as temperature, humidity, pressure, and air quality. The competition will encourage the use of low-cost, low-power hardware and software solutions that are capable of processing data locally, but also can operate autonomously over extended periods. And of course, we would like to foster competition, collaboration, as well as practical solutions that can not only contribute to improving weather monitoring, but also to enhance community resilience and adaptation to climate change. I would like at this point to welcome our speaker, Jonah Bessens, who is an R&D engineer at the Swiss Technology Innovation Center, CSEM in Neuchâtel, Switzerland. Jonah has been with us for the past 3 iterations of the competitions, and we welcome his contribution to the betterment of this competition. And Jonah has research interest in the tinyML embedded systems, but also wireless communications and RF-based localization. So Jonah, good afternoon and welcome to the tinyML webinar.
Good afternoon, Thomas. Thanks for the introduction. And I'm very happy to be here and to present for you the challenge of this year. And it's a bit a similar challenge as last year, because we believe it's a very nice problem statement, and we aim to continue with this also for 24 edition.
Thank you so much. So I will give the floor to you to make the presentation, and then after that we will call our colleague Vishnu to do the Q&A. Of course, everyone, if you would like to ask questions, you can post them on the neural network, and we will take the questions after the presentation is finished. So Jonah, the floor is yours.
Thank you, Thomas. I will share my presentation. Okay, and then put it big screen. Okay, good. So let's start with the presentation for the webinar. First, let us ask the question: what is embedded tiny machine learning? Well, embedded machine learning is where two fields come together. We first of all have the machine learning part, like with the neural networks, very complicated models. We think today about LLMs, so it's a very broad field. And on the other hand, we have embedded devices, IoT devices, which are wearable, like your smartwatch or your Fitbit, and they do something in an embedded way. They have all the processing on board to do interesting things. And what if we combine these two fields? Then we get tinyML. So we try to put machine learning on embedded devices. And this to make embedded devices more intelligent, more smart. And this can have good applications. And below, I will list you some applications for which it's used, and you can clearly see a trend that we want to use this ML for doing good things, to do good applications. For example, one is zero hunger and good health and well-being. And in this field, we took some examples. For example, we have on the left-hand side an app that can accurately detect plant diseases and therefore help the farmer and help their sales. In the middle, we have drones that help us to do agriculture, smart farming, by exposing less material to be used to manage the field. And on the right, we have a system that can detect mosquitoes based on sound, and also this with a very good accuracy. So these are examples where we show that we can do better for zero hunger and good health and well-being. But there are also other examples more related to land, to live on land and below water. For example, there is a rainforest connection where they use recycled smartphones together with solar panels in order to detect deforestation. So this can help us to detect this and then give warnings so that we can act upon. In the middle, you can see a technology used to detect elephants in the field. And on the right, you can see an application that uses tinyML to identify whales in waterways. So also helping us to improve life on land and below water. And then we also have examples related to climate action, more close to what is this problem statement about. And the first one is a ribbit network, which is a distribution of sensors, a distributed network of sensors used for greenhouse gas detection. And they also made this data set public. Then in the middle, you can see a robo-bee that is used as artificial pollinators. So also related to climate. And then on the right, we have smart AC systems that help us to reduce energy to heat and to cool buildings. So these are some applications. And of course, there is a big network behind. This is very interesting because this opens collaboration, this enhances the way we interact, and this is always very nice. And also one of the ambitions we have with this challenge to make collaboration possible and to learn from others. Now, what is this challenge about? So this challenge is about building a smart weather station. And the goal is to provide a low power and a low cost an easy to maintain weather station without any mechanical moving parts. So we don't want the turning wind speed detector. We don't want to flip the flipping bucket for detecting the rain. No, we don't want this. We want a device that can do this without moving anything. And this based on local tinyML processing. So all the processing happens on the device and is not sent to the cloud. And we have very nice prices sponsored by Edge Impulse. So we have the first prize for $1,500, second prize for $1,000, and the third prize for $500. So it can really give you an incentive to participate to this challenge. And of course, there is more information on the website itself. And I also give the QR code if you want to scan it with your phone. So the timeline goes from January 24 until May 20. So on January 24, we opened the registrations. Today is February 5th. We are launching this webinar, and we will have several milestones throughout the challenge. And this will be communicated later on during my presentation. So the introduction, it all started with the tinyML challenge in 2022, where CSCM, so the Research Institute where I work in Switzerland, to which we participated with the team, just like you are now participating with the team to this webinar and to this challenge, and where we built the system Aurora. And the system Aurora exactly has low maintenance, is low cost, and has local processing on board. And with our prototype, we were awarded with the first prize of the challenge, and we wanted to go further. We didn't want to just stop there. We wanted to make our dataset public, available to the community in order to build better models and better improve the performance. And therefore, we are organizing the edition in 2023 and now also in 2024 to make this happen. So the big picture is the following. So our board Aurora takes sound information through a microphone, as well as environmental factors like humidity, temperature, and pressure, and feeds this to a tinyML board that runs processing based on tiny machine learning, and then can detect whether it rains, and if so, how much it rains, and if there is wind, and if yes, how much wind is there. That's the big picture of our smart weather station. Now, how do we do this? We have several components. So we have like a microcontroller, we have an environmental sensor from Bosch, we have a battery, a lithium-ion battery, and we bundle that together to make this prototype possible. And to cover it from rain and from exposure outdoors, we printed a 3D. These are like we have made a 3D design and put everything inside to really have like an embedded system. And as you can see, the cost for a single prototype is quite limited. So it's low cost, and definitely if you would go for mass production, this can be made much less cost, and so we can improve the cost measure further. Now we did some improvements compared to our initial design. So we now have a much more better synchronization between Aurora and the reference weather station. You can see it here on the slide on the right. So we have like a mechanical weather station that gives us the labels for the ground truth. We need examples for the machine learning to do supervised learning. So therefore we use a ground truth to do this. And we solved issues related to the synchronization. We also improved the readout of the sensors from the reference station. So we have added a hardware for filtering to make the signal more clean. We also added a solar panel for like autonomous operations, so we can deploy it anywhere, like on the roofs and so on. And now we do wireless communication with Wi-Fi, and so we don't need to replace SD cards all the time, which is much more scalable. So how does the architecture look like? So we have, as I said, we have a mechanical weather station, environmental sensor, we have like a power management unit for the solar panel, and we have like a microphone to gather the sound information. Then we pre-process the data, we store the data temporarily, and then we send it from time to time via Wi-Fi to our backend and centralize all the data. Yes, and so the mechanical weather station is used to create labels for the database. So we have a dashboard, so we have a dedicated website. We built a website for this project where you can see some stats during the summer. So there it was over 30 degrees hot. Today is a little bit less. And so you can see the data in live from our station here in Neuchâtel in Switzerland. And we also provide the data set on this website. So today we have more than 100 gigabytes of data available for you. We have almost 2,000 hours, and this all comes from the station here that we deployed in Neuchâtel. Throughout this challenge, we will also evaluate your proposals. And so we aim to do that on different factors. So we are very interested in the accuracy. How well can we detect whether it's wind, whether it's wind, whether it's rain? This can be both like a classification problem, but can also be a regression problem. So in classification, we would output a certain level of zones. For example, no rain, a little bit of rain, a lot of rain. But we can also work on regression, where regression really tries to estimate the current level of rain at a certain amount of time and continuous output. We are also interested in the memory footprint because this determines the cost for the final deployment, the energy consumption, which determines the lifetime and the size of the solar panel that we need to make this possible, the latency. Again, latency is important. Latency, with latency, we mean the time it takes to invoke the machine learning model. And this is important because the shorter it takes, the sooner we can go to sleep mode, and thus we can also reduce energy consumption. Then the prototype, whether you make a prototype or not, this is always very welcome to see prototypes. This could also help to improve ours. So this is also a very nice axe to work on. And then, of course, documentation and code quality. I think that is in any project, this is very important to be able to let people build upon your solution. And therefore, this is also one of the factors that we will evaluate. And we will also give bonus points for successful evaluations on the test set of the challenge. So you can see on the database that we share, this is not all the data we have. So we keep a small fraction for our own in order to then later on evaluate your model on that test set to make sure that we have a common test set and that we can evaluate and compare the models submitted by the different teams. New since this year is also a Q&A forum. So we really want to lower the barrier as much as possible. And so therefore we launched a Q&A forum where it is possible to ask questions and also to read what others ask, in order to create a community around this, and also in order to respond to potential problems that you might have. For example, if you don't understand well how the dataset or how the dataset is composed, or you have issues with running a model, this can be added here, and we can have an interactive discussion. So you're all invited to join this Q&A forum, and also look from time to time whether there are new messages. There are no emails that are sent by default by this forum at this moment. So you're invited to check from time to time whether there are new questions and whether people asked or responded to your answer. So the timeline is the following. So we will have a set of checkpoints to make sure that you keep the vibe and you keep working on the project. And we will do everything to assist you in that. So at the end of February, we will have a proposal checkpoint. With a proposal checkpoint, what we mean there is a short document of 1-2 pages where you describe what do you want to do for this challenge. What is the hardware that you envision to use? What is the type of machine learning models that you like to use? What is the flow? How would you tackle this challenge? Would you first work on data preparation, the modeling, the prototyping? So how do you see this on a timeline? The team with whom you're working, so where you're coming from, and this just in a document of 1-2 pages. And then we will give most likely feedback on this proposal. And then this is like the starting point, and then you to get you off with a flying start. Then in the week of March 25, next to the Q&A forum we will also launch a live Q&A session for you, so you can ask questions live, and we will do our best to answer them. Then in April 15th, so almost 3 weeks later, we then have a model checkpoint where you can submit the model that you have until then with a short description, how it works, what is the performance you get until that time. And we will have a look at that, and we will try to give you some feedback as well in order to improve it. And then May 20th, we have the final submission where we will have all the deliverables that will be submitted. So it will be a final report on your solution. It will be the code to be able to evaluate your model on the test set. And we will provide a template for that, so you can easily interface with that. Ideally, a video of your solution to make it real and to show us something that is happening. And some pictures of the prototype, but that can also be included in the report. And in the report, what is important is really to focus on the highlights. What did you try? What did work? What did not work? The system architecture, the machine learning models. What is the architecture you used? Why did you use it? Did you compare it with other architectures? And then finally, of course, the performance evaluation, because we can do an evaluation from our side, but you're also welcome to do an evaluation from your side. For example, we have a large data set that we share with you. You can split it in a training set, in a validation set, and you can do the evaluation on the validation set and put that result already in the report. Yeah, and of course, you're also welcome to add your own database next to the one that we provide. That's perfectly feasible, and that's even very welcome to do. Okay, good. Then let's go, and I am already at the end of my presentation, what I prepared for you. So yeah, I suggest we go for now an interactive session. If you have questions, go ahead, and I'll pass the word to Vishnu, I think, at this time. So thanks a lot for your attention, and yeah, happy to help with any question.
Thanks a lot, Jonah. This was quite nice presentation. And of course, we are going into the interactive session, questions and answer. And of course, I'd like to invite Vishnu to take over the Q&A session. So Vishnu, the floor is yours.
Thank you very much. Jonah, thank you for that presentation. It's a great pleasure to see you again here. I remember your demo. I remember your presentation and demo in the Geneva. It's very, very comprehensive and excellent. Now, a couple of rapid fire questions, which is in the mind of everybody. Can the participants from last year apply again?
Yes, they can, and they are even very welcome to do so, because last year we had the conclusion was that most of the teams didn't have enough time to make like a nice solution at the end, but they all started very well. So we really encourage them to continue and to participate also this year. Yes.
That's great news. Thank you very much. I'm sure they would be very delighted to hear that. And the next one is, we always get this question. I remember last year also we had this question, that can participants bring their own data?
Yes. So there the question is also a big yes. So we, as an organizer or co-organizer of this challenge, our aim is to lower the barrier to participate and to get you off with a flying start. But it's not our aim to only force you to use our data, not at all. So you're really welcome to come up with your own data set, build your own prototype, and use that data in addition maybe to our data to further refine your model.
Great. Thank you. You mentioned about prototypes. That's very exciting, and apart, you mentioned about non-moving parts. It's very clear that part is very clear, that you should not have any moving parts. But what are the other considerations? So suppose, I'm a very hands-on person. I would like to really now build a prototype with it. What are the other design considerations for, let's say, if I have to make a hardware prototype for this, what are the design considerations?
So for design considerations, well, ideally it will be waterproof, because the final goal is to put this outdoors. and to detect rain and wind. So if you can make it waterproof or at least water resistant, this is already very good. For hardware considerations, I think the easiest is to start with development kits. Try to connect like a microcontroller with the sensor. Try to get the data, gather the data, and run the model based on that. So regarding hardware, we don't have specific constraints or specific demands. So we let that up to you. There is also some hardware support, from what I understood. Maybe Thomas can give a bit more information on that. Yeah, it's very open. We don't put any constraints. So I would say use what you prefer, and yeah.
Just to add especially on the hardware, right? So last year, most of the teams who joined the competition received some hardware support, Arduino and Seed Studio hardware. I encourage those teams to utilize that hardware that they had last year to use it for the sake of this competition. But of course, we also have new teams that will be formed, new participants that will join the challenge this year. We still have some hardware left, and we are planning to give out to those teams. But of course, they have to show that they need this hardware. It's not like we just give out to everyone. So those teams that are participating and will planning to submit a solution to this competition, and of course they have the need for hardware, then we will be able to provide some kind of hardware support to them. And of course, we are not limiting the hardware to Arduino and Seed Studio hardware. No, you can also use your own custom hardware. You can use Raspberry Pi or what kind of tinyML or IoT related hardware you think is possible. Because like in 2022, John and colleagues, they had their own, I would say, custom hardware that they used for the sake of the competition. So it's kind of open to everyone to come up with interesting new perspectives, new designs, and let's see where this goes.
Very good. Thank you, Thomas.
Yeah, absolutely. Yeah, I think John, I still remember your hardware. It was very exciting. I remember you opened it and showed it also. I think that is very exciting to see that real working. And there's a chance of getting hardware for the teams as well. I think that is, as Thomas explained, that is quite exciting as well. Ground truth, yes. So I see that you have added ground truth. That is super interesting. So can you tell us a little bit more about it? Like, it's very obvious, but why did you do that? Secondly, how did you time synchronize between during your measurements? Thirdly, can I have access to can the participant have access to the ground truth as well? What can you comment a little bit more about this ground truth? I remember last year it wasn't there, so you added it newly.
Yes. Okay, so why do we want this? So for every supervised machine learning today, we need some examples. So suppose we do it with sound, we listen to the environment and we hear something, but we don't know, is it raining or not? So we need we need to know this in order to train the model. So therefore, that's really the motivation why we add like a conventional weather station, which is mechanical. So it's really a mechanical station with like the turning thing for the wind and the flipping bucket. So it's really a bucket that flips when there is a certain quantity of water. And this flip is detected with a sensor, which generates an interrupt, like a small peak, and which is then detected by the microcontroller, and with which we know that at this time we had this amount of rain in the bucket because it flipped, and we know the exact quantity of water that can go into. So yeah, and this is also something we give to the participants. So in the data set that you will have, or that is online, we have both audio information, and then for every audio information of a second, so we take samples of 1 second, we also add the information from the mechanical weather station. And how do we synchronize that? Is the following. So these weather stations, so these mechanical weather stations, they have just like two cables output. Actually, it's when the bucket flips, it generates a signal, and that signal is detected by a microcontroller. So we have a cable for the wind, we have a cable for the rain. We connect that to the microcontroller that also is connected to the microphone, and so we have everything connected to the microcontroller. So the synchronization is there, as everything is managed by a single device. So and this is then added to the data set that we share with the participants. And so the data is sampled in windows of 1 second. So every second we take like 1 second of audio, and then we look if there are interrupts from the wind sensor, if there are interrupts for the rain sensor, and if yes, we add it to the one line in the database, and then for every second we have a new line. I hope that was a bit clear, Vishnu. If not, don't hesitate to say.
No, it's super clear. Ipiana is asking, is it mandatory to develop a custom web-based system for collecting and analyzing data as a central database?
Thank you for this question. No, not at all. The goal of the challenge is really to work on the embedded side, on the interesting part. And so how to put machine learning on an embedded system, and all the collection of this data, that is what we aim to help you with as an organizer, to make sure that you don't have to deal with that. So you can just download the data from our website, start training the machine learning model based on this, and this should be sufficient to get you off with a flying start. So from your side, there is no real need for a central database, a web-based system. This is all in place, and this is there for you.
Great. So then my next...
Just a quick addition, Vishnu. As much as I think John also pointed out during the presentation that the data that is available is to help you to get on a flying start. But of course, I know some people like to experiment with more things, being innovative. We don't limit that. So if you feel like you have maybe some idea on how you can implement your smart weather station in some unique way, you're welcome to be innovative, you're welcome to be creative, as long as it follows the principles of tinyML.
Great. Yeah. Thank you, Thomas. Yeah. I think that now that is clear. Maybe from last year, the learnings, Jonah. By the way, for the participants, there is a wealth of information webinars which Jonah had given in our portal, AI for Good portal. You can go there, search for it, and there are, I believe there are like three webinars which are available. I would suggest if you're participating in this year, I would really suggest to go back and look at those recordings. Those webinars are there. But can I ask you, Jonah, what are the learnings from last year? I mean, what did the participants do well and did not do well last year?
Yes, good question. So from last year, we got some interesting submissions, and there what they did do well is they followed up well on the checkpoints that we did. So we saw that those teams that had a final submission followed us throughout the entire journey, and they submitted their checkpoints throughout the challenge, which we really appreciate, because this helps us also to see what's going on, and also it helps us to see how well they're doing. We also saw that sometimes the contact with the participants was a bit less, and therefore we organized also during the challenge a Q&A session through the challenge. So that was also a learning we had, that we really need to be there for you, and we try to do that as much as possible. And that's also the reason why this year we also launched a Q&A forum to improve the interactivity of the challenge. And regarding to the results, I can say we had interesting results. We had results that were mainly based on like conventional models, let's say, which are more on convolutional neural networks. This year we would also, if possible, like to see some submissions that try to work also with time series models, so like LSTM. Of course, not too big, because they ideally need to fit in the embedded system, but also to have some exploration in this direction. I think for this year would be very interesting. And another thing, what we noted, and that's related to the question of Dennis, is that most of the teams were focusing on the intensity of rain, so but not on the amount. And this is also something we would like to work on this year, is that maybe we don't need to detect intensity, we can directly detect the amount. Because what we saw from the database that we currently have is the mechanical weather station. They have like a flipping bucket, and it only flips when the bucket is full. So when it just starts to rain, the bucket is not yet full, but still we hear the ticks on the head of the of our prototype. So which means that actually with audio you can do even better than with a mechanical weather station, which means that the ground truth that we currently have shows some limitations. And one of the interesting directions is, how can we still, with these limitations, how can we propose a model that can do better than the ground truth that we currently have, and that can detect the rain from the moment that it starts to tick? Because then we can even show that we cannot even do lower cost, but we can also do it in a more accurate way. Yes.
Yeah. I think that answers Dennis' question as well. Yeah. I think I remember this discussion about the intensity, and that's a good point actually. I also think that there was some discussion on the optimizations, quantizations. I'm looking at my notes from last year, and it is quite clear that we had this kind of solutions with comparing quantized and unquantized properties of the models. What is your guidance on the quantization part? What should the participant look at for optimizations? This year, you also have introduced latency. I see that you have introduced latency. So with that in mind, what should the participant look at for optimization and quantization?
Yeah, so for quantization, this is an important part, because usually when we train machine learning models, we do that in floating point 32. So we have a lot of precision, but then if we want to put it on the device, we don't have enough memory to do that. So there, quantization comes into play. And yeah, we welcome the participants to work on that. Although we also saw that usually participants are not only working on this challenge, we also have other duties in our daily life. So I would also try to put your effort where you think you can bring the most added value. And this can be at different phases. You can do you can start with a baseline model and try to optimize as much as possible to work more on the latency aspect, on the memory footprint aspect. But you can also, if you believe that with your background you can have more added value in the model design, then you can focus more on the accuracy aspect. So there is no single objective. All these objectives that I list in the presentation are important. But the main goal is really, to propose something for the tinyML community and to see what can we do in this direction for this problem statement.
Sure. Yeah. Thank you very much. I want to ask about prices. Do they still remain the same?
Yes, so we have exactly the same prices as last year. So we have Edge Impulse as our sponsor. And so the first prize is $1,500. Second prize is $1,000, and the third prize is $500.
Great. And publications. So there are many students, there are many scholars who like to publish their results. Can they publish the results? And would you encourage them to do it? Or can you tell a little bit more about that?
Yes, of course. They should publish if they have nice results. I think this is also one of the objectives the teams can have to participate to this challenge, to propose something new, innovative that can help the community to advance further. And so we as an organizer, we ask you some content to be able to evaluate your results, but this can be done in a way that does not harm the publication of a later technical or scientific paper.
Great. About background noise. So we had this discussion last year. There was I remember there was data collection near traffic or something like that, where there was background noise, which tends to affect the data collection. So I want to ask you, what are your comments on that, and how to mitigate this problem?
So as it is really like a real life deployment, so we put it on the roof of our building here in Neuchâtel. It is a real data set. So everything what's happening around us, we capture it. For example, during summer we didn't have the heating on. From autumn the heating started. So these are things that change a bit the environment, but that also increase diversity in the data set, which is again good for the machine learning model. So what we share is really the raw data. So it's not filtered. There is no background noise filtering that has been done. And this is something that we let to the participants to see whether a model needs a pre-filtering, or whether the model can learn even with a bit of noise what is really happening. This is one of the insights that can be gathered, and that I let to the participants to find it out.
Yeah, thank you very much. Yeah, I think that makes sense, and I believe this is a very exciting competition. I think this is a great opportunity as well. And I believe literally you are the best judge. So you have done it. So you are the best judge. Thank you so much. That's all the questions that we had. Thank you, and thank you, Jonah, for very patiently answering all the questions. Back to you, Thomas.
Thank you very much, Vishnu, for the Q&A. And of course, I would like to take this opportunity to thank you, Jonah, for the time, as well as presenting all these interesting stuff. Of course, not only presentation, but also organizing takes time to prepare the data, to prepare the content itself. So a big thank you to that. I know that there will be more opportunities to collaborate, especially to have like Q&A session later during the competition, but also in the forums, people will be asking questions, maybe others through emails. So thank you for your help.
My pleasure.
Okay, so at this point in time, I would like to close the session. It's been a wonderful time that we had. I would like to thank everyone who joined this session for sparing your invaluable time. And also a big thank you to Vishnu, a big thank you to Jonah for the time. A quick note, please note that the challenge is open for registration and participation. You can already join. I've shared the link on the neural network. So please join and create your teams, start working on it. As John already pointed out, we have several checklists or check marks where you can submit your proposal, you submit your code or model, and then final presentation. So in the next 2 weeks, that's where the proposal is due, I think on the 26th of February. So this is 3 weeks, sorry, in the next 3 weeks. And of course, we have several prizes that are lined up for you. So don't hesitate to join the competition. And apart from this tinyML challenge, we are also going to launch more competitions, the Machine Learning 5G Challenge, the Geospatial AI Challenge, and other competitions. So please be on the lookout at the AI for Good program page. But also in May, we have the AI for Good Summit in Geneva. You can registration is open already. You can register to join the summit, either in person as well as online. So I'm looking forward to your participation in the 2024 edition of the tinyML Challenge. And thank you so much for joining the session. Have a very good day. Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.